All right, in this video we're going to look at how to graph parabolas from the equation. So remember, the quadratic is the name of the equation, parabola is the name of the graph. So here I have 8 quadratic equations. Some of them I've given a bit of thought into it so that they would actually come out nicely, but towards the end I just chucked in some random numbers, so it'll be interesting to see how they actually turn out. So I'm going to scroll down now. Hopefully, if I keep the page like this, you can see the questions here. I'm going to draw my graph here and do all my working out on the right hand side. Okay, so I try to start off easy and then we're getting harder. Things are getting harder. So the first two, you can see they've already been factorized. Okay, so I'm going to do the first one, y equals x plus 3, x minus 1. Now for some of you, you'll be able to see the x-intercept straight away, but for others, you might have to say, well, let's x-intercept, let y equal 0. So we have 0 equals x plus 3, x minus 1. Now when something equals 0, if you've got two things multiplying by each other, it means one of them has to be 0 or both of them can equal 0. So we say x plus 3 is equal to 0 or x minus 1 equals 0. Okay, so we just separate the brackets. Sorry, writing's not that best. X plus 3 is equal to 0, x minus 1 is equal to 0. And that's called the null factor law. So basically, if you have two numbers, let's say a times b equals 0, it just means one of them has to equal 0. So let's say if a was 2, that means b equals 0. Or if b was 3, that meant a would have to equal 0. So that's all the null factor law is. So you don't really need to know too much more than that, because we've been doing quite a bit of it. All right, let's solve for x. So x can be -3 or x equals 1. And you could, for most of you, you'll be able to tell that straight away just from looking at your equation. Now, what we also need is to graph is the y-intercept. Okay, so the y-intercept, we let x equal 0. So we're going to have y equals 0 plus 3 times 0 minus 1. So effectively we've got 3 times -1, which is -3. So I've got a bit of writing there. Now, for some people who do write messy like me, I do say start putting squares around. You don't have to do it in a different color, but just put squares around your important information. Okay, so it's just a nice thing to do for your lovely assessor, which is me. Okay, so it's just easier for me to see. Instead of having to search or working out, I can say, all right, she knows the x-intercept and she knows the y-intercept. Now, the other thing we need to do is your turning point. Now, remember, your turning point is halfway between your x-intercepts, so you can add them together. So -3 plus 1, which is -2. And then, whoops, I should have done that here. Divide by 2. Divide that by 2. Whoops, not -2, sorry. And -2 divided by 2 is -1. And when you think about it, if we were to graph that, and here I've got a scale, so I should really be a little bit better with my scale. Let's see what I've got. Okay, it's going to be a bit hard to see here. So we've got x, we'll do 1 there, and -3 is here. So there's our x-intercepts. We have a y-intercept at -3, so which is here. And my turning point is at -1, so halfway between these two, and you can see that's right. So the x-coordinate of our turning point is there, but we also have to find the y-coordinate. So let's just go up here and do that. So when so this part here is just working out the x-coordinate. You also have to find out what the y-coordinate is. So all you do is substitute in -1 into your equation. So -1 plus 3, -1 minus 1. So -1 plus 3 is 2. -1 times -1, sorry, -1 minus 1 is -2. Y equals -4. Okay, so there, the turning point coordinates are -1, -4. And you can just check that out. So -1, -4 is here. And that looks like about right, because if I was to join all those dots, and I might do that in a different color, you can see it makes sense. So I already know that it's a positive parabola, okay, so it's already around the right way. And if I join the dots, okay, it's symmetrical. Now with the rest of your graph, just go up like that. Okay, so there's your equation. But before you finish, make sure you actually label it. So remember your x-intercepts were at 1 and -3, and your y-intercept was also at -3 down there. The turning point was -1, -4. Okay, so as long as you've got all those features on there, you've drawn your graph. Well done. Okay, let's move on to the next one. So remember also at any time you can press pause and have a go at doing it yourself. So this one here, we're doing y equals 2, x plus 2, x plus 9. So we do the same thing. Okay, so the x-intercepts, let y equal 0. So we have 0 equals 2, x plus 2, x plus 9. Now your this 2 doesn't make any difference to your x-intercept, so it's just this what's inside your bracket. So because if we were to divide both sides by 2 to get rid of this 2, 0 divided by 2 is still just 0. So we're going to have x plus 2 equals 0 and x plus 9 equals 0. So that means x is -2 and x is -9. Okay, so there's our x-intercepts. Our y-intercept, let x equal 0. So we're going to have y equals 2, oops, can I just go back, put that 2 in, 0 plus 2, so I'm just going to do the 2 there, and 0 plus 9. So we've basically got 2 times 2 times 9. So 2 times 2 is 4, 4 times 9 is 36. Okay, so your y-intercept is at 36. So getting a bit messy, so I'm going to start putting a little square around important things. Our x-intercepts and our y-intercept. And let's go back to black. Okay, so the next thing we need to do is our turning point. Let's do it up here so I've got a bit of space. So remember your turning point is, we're doing it for x. So the x coordinate of the turning point. We add the two x-intercepts together. So -2 plus -9 is -11. Divide that by 2 and we get -6.5. Okay, so that's the halfway point between, oops, sorry, that was 5.5, halfway point between the two of them. Now, to get your y-intercept, we've got to substitute 5.5 back into this. So this is where it can get tricky, because remember, you need to be able to do this without your calculator as well. So -5.5 plus 2 gives you -3.5, and -5.5 plus 9 is 3.5. Okay, so this is crazy. All right, I am going to use fractions because I am much better at doing fractions than decimals. So 2 times 3.5 is the same as 7/2, and that's 7/2. And I've got a negative here, so I'm just going to put the negative out the front here. So 7 times 7 is 49, times 2 is 98. Don't forget the negative. 2 times 2 is 4. And then 98 divided by 4. So I can do 98 divided by 2 is 49 on 2. And then, let me just think. Let's write that as a decimal. -24.5. Okay, so running out a bit of room, so I'm going to just put squares around it. So here's our x coordinate of our turning point. And there's our y coordinate of our turning point. All right, so with the axes, so I've got a blank axis here, and I've got to think about my scale, because before it was fine because I could just go up in ones, but here I've got a 36 and a -24. So I've got to think of my scale, and I can see I'm going up by 3s here. It's still not going to work with 36. So maybe if I went up by 20, might be a bit better. So my scale is going to go up by 20s. Okay, so it's going to be 40 there. So 36, 30 is halfway, and then 36 is about there. Okay, so that's my y-intercept. -2, -9. So your x-axis doesn't have to be the same scale as your y-axis. Okay, so just because we went up by 20 along here doesn't mean you have to do the same on your x-axis. So I'm actually just going to, let me just think what I could do. I might just go up by 1s. So there's -2 there, and -9 here. My turning point is halfway between those two, so at 5.5. And let me just fix that up. So, oh, sorry, I just had an alert come up. 5.5 and then -24.5. So again, I do have to go up, well, in this case down by 20 along my y-axis, but my x, it doesn't matter. Okay, so 24.5 is about there, halfway. Okay, so you're probably sitting there thinking, oh, you're not exact, but it doesn't matter if I'm not exact as long as I'm close, because you'll see in a sec if I join my dots, so my y-intercept going through the first x-intercept, going through the turning point, going through my other x-intercept. Okay, and the important thing is actually labeling it correctly. So I've already got -9, -2. My y-intercept I didn't write, so let's write that as 36. And then my turning point is at -5.5, -24.5. Okay, so I'm a bit worried I've made an error, so I'm just going to quickly check it on my calculator. Okay, so all right, so that's all good. I just checked it on the calculator. So make sure you also check it on the calculator, because and if you've forgotten how to do that, you really need to go back and watch the videos. I'm not going to teach you again how to do the calculator on here. All right, let's move on to C. Otherwise, it's going to be a very long video. Okay, so for question C, it's in expanded form, x squared minus 6x minus 7. For this one here, as it is, I can tell two things. It's a positive parabola because the coefficient of x squared is positive, and the y-intercept is -7. So remember, whenever you've got a constant, that's your y-intercept. So we've got a y-intercept at -7. You can factorize it now to find the x-intercepts. So, or you can find the turning point, it doesn't really matter. I might just do the turning point first. So your turning point is at -b/2a. So remember, your value of a is the coefficient of x squared, the b is your coefficient of x, and c is your constant. So we've got -b here, so we've basically got -6/2 times 1. And so 2 negatives gives you a positive, so we've basically got 6 divided by 2, which is at 3. And then when we substitute 3 into our equation, we get y equals 3 squared minus 6 times 3 minus 7. So we've got 9. 6 times 3 is 18, and then minus 7. 9 minus 18 is -9. And then minus 7 is -16. Okay, so I've got my y-intercept and my turning point. So just so we don't get mixed up, let's just put a nice little box around that. Here and here. Now for your x-intercepts, first of all, you can use the quadratic equation whenever you see it in expanded form. Okay, so I can see this is in expanded form, so I can go ahead and use the quadratic equation. I can also expand anything that's factorized. So if I prefer to use the quadratic equation, I will expand this first and then use the quadratic equation. But think about how you could factorize it. So remember, two numbers when multiplied will give you -7, and when added will give you -6. So think of the factors of 7. Basically, we only have 7 and 1. So 7 times 1 will give you 7. But we've got -7. So it means that one of these numbers have to be a negative. And when you add them, you have to get -6. So if I make the the number 7 negative, that gives me -7. And when I add them, I get -6. So when I factorize this, I get y equals x minus 7, x plus 1. So if you were to expand this, you would get that, our expanded form. Okay, so now I can find my x-intercepts. Let y equal 0. So we've got 0, and you might already know what they are, but let's just do the working out anyway. So that's a 1. So x minus 7 equals 0, x plus 1 equals 0. All this here that I'm working out, I wouldn't actually be doing, because you should be able to go from this and see straight away that your x-intercepts are 7 and -1. All right, let's think about our scale. So we've got a -16 here for our turning point. So I actually need to think about my scale. If I was just letting it go up by 1, would that fit on? So 5, 10, 15, or we would just be below. So let's make it 1. And we write for our x-intercepts. Okay, so let's do our x-intercepts first. So we've got 1 here and 1 at 7. Remember the previous two times to get our turning point, we actually added our x-intercepts together. So 7 plus -1 would give you 6. 6 divided by 2 would give you 3. So it's just another way of doing it. Y-intercept is at -7. And then our turning point is at 3, -16. So let's just find 3, and 16 is just going to be down here a little bit. Okay, I haven't labelled it because sometimes I feel like I draw over my labels. So I'm just going to join the dots. Now, when you're drawing it, if you want it to be symmetrical, see how this dot is 1 away. So it's basically then going to be 1 away from this dot. So there's your other point. Okay, so it's going to be symmetrical. Whoop. Hopefully by now, I know when you first started, some of you could not draw it. Well, that didn't really go through the point. How ironic that I'm talking about how you couldn't draw a parabola and then I can't. But you should by now be able to draw quite good parabolas. So that's 7, -1. I'm just going through this quickly. Y-intercept is at -7, and then our turning point is at 3. So I'm just going to draw 3, -16. Okay, so make sure you always label your graph, because even if you make an error here, if I didn't label that as -1, I would get that wrong because clearly it's not going through -1. And I'd probably be able to do it a bit better if I was doing it by hand, not on the computer. All right, all good. Let's move on to the next one. Okay, so we're doing D. So we've got y equals -2x squared plus 8x minus 24. Now this is telling me straight away that I have a y-intercept at -24. Okay, so remember your constant. It's also telling me that I have a negative parabola. So remember the coefficient of x squared is telling you whether it's a positive or a negative one. So this is a -1. So it's got to look like that. So if it's not looking like that when I'm done, I've made a mistake. Okay, and don't think, oh, but I've done everything right. Oh, it must be right. Okay, no, if it doesn't look like that, it's wrong. So you need to be able to, when you first start, say, is it going to be a positive or is it going to be a negative parabola? And then at the end, you'll be able to say, okay, it kind of looks like what it should, or, oh, hold on, it's a positive parabola when it should be negative. Okay, also, what this is telling me is to take this -2 out as a common factor, because I can see 2 will go into 8 and into 24, and will make it easier for me to factorize if I need to factorize it. So we'll put the -2 into that, will give me -4. And just, yeah, so just be careful with your negatives if you do have to take out a negative. Now this is one I did give a bit of thought to, so let's hope that it works out nicely. So two numbers when, oh no, didn't, oh, I should have put a positive there. Let me just think. Yeah, bummer. Okay, so I did want 6 and 2 to be my numbers, but it's not going to work out. So let's just think what else we could do in this situation. So what I was thinking, okay, so I'm thinking aloud here. So 2 and 6 gives me 12. Okay, and they either both have to be positive or both have to be negative to give you a 12, positive 12. So we have either 2 times 6. So when we add them together, we get 8. But if we had negatives, okay, that would also give us positive 12. But, oh, got me rushing. But that would give us -8. Okay, and we want -4 here. So we can't use 2 and 6. We can't use 12 and 1. We can't use 3 and 4. Okay, so I will then say, well, I can either complete the square or use the quadratic formula. For this one, I would actually use the quadratic formula. So just thinking on my feet here. Hold on, I'm just going to have to pause for 1 second. So I was just thinking if I could still take the -2 out as a common factor, and of course you can. So I'm just going to be factorizing, because I might just, oh, I'm still leaving the wrong part. Just want to get rid of this because I'm just going to be rewriting the exact same thing. All right, so I'm going to just deal with the equation as it is and see how I've brought that -2 out. Okay, you could either use the quadratic formula with the original, or you could use it by taking out the common factor of -2. When you take out the common factor of -2, you're only dealing with what's inside the bracket, so you can just ignore that -2. So your coefficient of x squared is 1. Your coefficient of x is -4. And then your constant is 12. So then we use the quadratic formula. I don't have space here to write the quadratic formula, so I'm just going to substitute the values in. So the first one, -b, so that would give you a +4, plus or minus the square root of b squared, which is 16, minus 4 times a times c over 2a, which is just going to be 2. So we have 4 plus or minus, what have we got here? 4 times 1 times 12. Oh, this clearly has no x-intercepts. Okay, so I'm going to get the square root. 4 times 12 is 48. So 16 minus 48 is going to give me a negative number. I don't have to work it out because at this point I know I have no x-intercepts. So in that situation, let's think about what we can do. We have a y-intercept at -24. Okay, might just put a red box around that. We have no x-intercepts, which is a bit of a bummer. And our turning point. So let's do our turning point now. Okay, so turning point, I'm just going to use this equation. So we have -b, which is 8, over 2 times a, which is -4. So your turning point is going to be at 2. And then when we substitute 2 into here, -2 times 2 squared. Sorry, I'm just thinking as I'm doing this. Minus 24. 4, -8, 16, minus 24. So what do we have here? 8 minus 24, so we have -16. Okay, so there's our turning point. When you get into a question so deep like this, you constantly question whether you've made a mistake or not. Oh, gosh. All right, so let's graph what we have. So we have a y-intercept at -24. Okay, so I might go up by tens. So we're going to call this -10, -20. So we're going up by 2. So -24 will be here. Turning point is at 216. So let's go to 2. Oh, this isn't going to be best. The best one. I'll explain in a sec because we don't have any y-intercepts. So I'm basically just going to be down here. Okay, so there's our turning point. And when I'm graphing it, remember it's got to be symmetrical. So if I'm here at -24, okay, and that's 2 away from here, so that means if we go to that side, it's going to be symmetrical, and that will allow us to draw it. So even though we don't have any x-intercepts to help us draw our graph, we can still draw it. And I was laughing before because it was going to be so small down here, and we've got all this space, but that can't be helped. Okay, so let's just quickly label it. So our y-intercept is at -24, and then our turning point is at 2, -16. All right, I'm going to pause it just so I can check that I am actually right. All right, so that's good. It was all right. Means I don't have to do the question again. All right, what are we up to? E, we're 26 minutes in. So if you want to, you can pause. I don't mind. You can stop listening to me anytime you like. So we've got y equals x squared plus 4x minus 2. So this one here, again, I know it's positive and we have a y-intercept at -2. Can I factorize it? So two numbers when multiplied give me 2 and when added give me 4. Not really, because the only factors of 2 are 1 and 2, and they don't add to give 4. Now what I might do with this one, instead of using the quadratic formula, I might actually, I wanted to use the turning point form for one of them. Let's see how we go with the turning point form in this one. So remember your turning point form, we halve the coefficient of x. Oops, which isn't B, sorry. And then add it. Hold on, I've missed out on this. Sorry. Okay, so then we do a half. Sorry, I forgot. 4/2 squared minus 2. Okay, so this factorizes to be x plus 4 on 2, so it's 2, x squared, minus 2 squared, which is 4 minus 2. So we have y equals x plus 2 squared minus 6. Okay, so what I've got it in now is turning point form, assuming that I haven't made any mistakes anywhere. So I can see straight away my turning point, that's why it's called turning point form, is at -2, -6. I know my y-intercept is at -2. Let's just highlight a few things. Okay, I just like a little bit of colour, so there we go. Okay, and remember turning point form helps you see the transformations. So for this one here, it's been shifted down 6. Okay, so your basic parabola x squared has been shifted down 6 and to the left 2. Okay, so now we need to do our x intercepts. Let's just go like that. We're going to have surds. Oh, okay, so we can use difference of perfect squares because of this minus sign. If there was a plus there, there wouldn't be any x-intercepts, but that minus sign there tells me that there are x-intercepts. There are 2 x-intercepts. So let's work out what they are. So remember the difference of perfect squares If you're not sure, make sure you go back and revise that. So we're going to have, testing my memory, x plus 2 plus the square root of 6, x plus 2 minus root 6 equals 0. Okay, and I should have a y equals there. So that's what this will be if you were factorizing it. Now let's just think about this. So we've got x is either going to be -2 minus root 6, and I'm just going to write the other one here, -2 plus root 6. Now, the square root of 6, you're probably thinking, well, it can't be simplified because there's no perfect square that goes into 6. But what you need to do is say, well, what's the closest? Okay, so the square root of 4 is 2, and then the square root of 9 is 3. So I know the square root of 6 is somewhere between 2 and 3. So it doesn't really matter that we don't know what it is exactly as a decimal, but the fact that I know it's somewhere between 2 and 3 will just help me graph it. So if I go on my axes, and I'm just going to do everything up by 1 because I'm pretty sure I can. So my first x-intercept will start at -2, which is here, and then we're taking away the square root of 6. So I've got to take away 2, and it's going to be somewhere between there. Okay, because -2 and then the square root of 6 is somewhere between 2 and 3. So I've got -2 minus some number between 2 and 3. The other one, -2 is here, plus square root of 6. So we're going in this direction, so we're somewhere here. And I know my turning point is at -2, which is good because otherwise I've made a mistake doing my halfway point, and then -6, which is here. And my y-intercept is at -2. So everything's matching quite well, which is good. Okay, so let's sketch. Remember, if you wanted to do it symmetrical, just put the other point on. Doesn't have to be exact. Oh, look at that, that's terrible. Okay. So, really can't be bothered putting all these points in, but I will. So we've got, now usually we write the positive number first, so I'm going to do that. Root 6 minus 2, and this one here is, well, they're both negative, so it doesn't really matter. -2 minus root 6. And then your turning point is at -2, -6, and then our y-intercept is at -2. Lots of -2's. Okay, I'm just going to assume that's correct because otherwise I'm going to be doing this video for a while. Let me know if I've made a mistake. All right, what are we up to now? F. Okay, so we have y equals, and my son's going to be home from school any minute now, so I don't really want to keep doing this. All right, so we have y equals -x squared plus 5x plus 8. So can't be done, it can't be factorized, so we're going to use the quadratic formula. I know my y-intercept is 8. I'm not going to do that. I'm just going to go straight into the quadratic formula. The value of b is 5, so -5 plus or minus the square root of 5 squared, which is 25, minus, now I've got a negative here, so I'm going to use brackets. So minus 4ac, so 4 times -1 times 8. Oh, we're going to get a big number there, and I think we're not going to have any x-intercepts. 2a, so it's just going to be -2. Now, I'm not going to go any further. Oh, no, that's going to make that a positive. Okay. Sorry, thinking aloud, thinking aloud. I thought this is going to be a big number, so taking away a big number, but there's a minus here. So we're going to have 25, -4 times 8 is -32, so we've got plus 32. Oh, isn't this horrible? Why can't it be nice? And we've got a negative down the bottom, which isn't nice. Okay. Let's do this. 57. Oh, what a horrible number. Whose idea was this? Okay. This is just a horrible one. You would never get anything so horrible. Okay, you wouldn't be expected to graph that because we can't even cancel anything out. And 57, I'm pretty sure, is a prime number. So we can't even, definitely it doesn't have a perfect square. So what is that roughly? So the square root of 49 is 7. So it's somewhere between 7 and 8. Okay, do you know what? I'm just going to maybe do this one on the calculator. I know I wasn't going to do any on the calculator, but this one's a pain in the bum. And I don't want this to go on forever. So here, how about we do this one on the calculator? Teach you how to do it on the calculator. All right, I've just got to make this a little bit smaller. Okay. Oh, let's move that over. Move you over a bit more so we can actually see the screen. Here we go. All right, so let's just go to new document. All right, so I'm just going to graph it first of all. So what are we doing? F, negative x squared plus 5x. Would it be funny if I just made a total boo-boo and it was actually quite a simple one? Okay, so you can see your x-intercepts there. I'm just going to move this out of the way because it's annoying. Now, with your x-intercepts, remember, what do we do? 0. So to the left and to the right. So you can see it's there at negative 1.27. Let's do the other one. I'm going quickly, but remember you can pause at any time. And the other one's at 6.2. To get your y-intercept, just go to trace, graph trace, and this will also give you any value you want for x. So I can see my my y-intercept is at 8. You can't really see that. It's just a little bit out of screen. There we go. Now my turning point, I actually need to go change my window a little bit because I can't see it. My y maximum. What could we do? Let's just do 20. Oh. Okay, and it's a maximum, so we want to do maximum. Left to the right, there we go, 2.5, 14.3. So there's all the features using your calculator. If you wanted to use the other screen, sorry, just bear with me. I'm rushing because I'm under time pressure. Okay, add calculator. All right, so your x-intercepts you can always use solve. So negative x squared plus 5x plus 8 equals 0, comma x. Okay, so there it is, and you can see that's pretty much what I got before when I used the quadratic formula. To get your turning point, you can use, there's actually 2 things you could use. You can complete the square if you wanted to. So I'm just going to go back and highlight this and go copy. Okay, so you can complete the square that way, and I can see that the turning point is at 5 over 2, 57 over 4. Or you can do calculus function maximum, but that'll only give you the x coordinate. So completing the square will give you both of them. The reason it's written this way, not with the brackets first and then the 57.4 over 4 on the other side, is because remember we usually just put a positive number and then the minus. So still completing the square, is just written differently to how you're used to seeing it. All right. The next 2, actually, I'm just going to do on the calculator again as well because I don't know what it's going to turn out to be like. I'm sorry. So you can obviously do it on your calculator. You can obviously do it by hand, and then you can check on your calculator. So I'm just going to type it in so you can actually see the answers. -3, comma x. And my calculator, oh, look at it. There we go. It's got a 37. My calculator's in exact mode. So if you're not getting surds, you just need to go to Doc Settings, Document Settings, and change it to exact here. Okay, so you'll get that. And to find out what the decimal is, if you want to graph, just Control Enter will give it to you. But I can promise you anything that you're going to be assessed on won't have horrible numbers like that. So what else are we going to do? Complete the square. So algebra, complete the square. Remember, I can just highlight this. I can highlight the whole thing. Control C, middle, Control V. There it is. So what do we have? Negative 1 over 6, negative 37 over 12. If you want that as decimals, Control Enter. Oh, it's expanded it for us. It hasn't actually done it in decimals. But you can do 1 over 6 quite easily. Sorry. And 37 over 12 to see what that's going to be as decimals. There it is, 3 over 0.08, and your y-intercept is always your constant, so it was negative 3. You can go back and graph it if you want, so tab, clear all that. Now I know I've already, 3x squared plus x minus 3. Okay, so again, you can find out your x-intercepts. Now, with your graph, if I just move this, okay, so it's found one x-intercept for me. Don't always rely on this. You should be writing it in exact form. Okay, so if we go back to the calculator, to our x-intercepts, which are here, you should be using the exact form, not the approximate, unless it states that you should be using your approximate. So in your assessment, you won't have your calculator, but there'll be nicer quadratics to actually graph. Okay, let's do the last one. So solve negative 2x squared plus 3x minus 10 equals 0, x. Okay, so here we've got false. That tells me there's no x-intercepts. So I know my y-intercept is negative 10. The other thing I can do is my, my turning point. So I complete the square. I'm just going to highlight this. Okay, the only thing I need to delete is that equals 0. It won't work if I don't put it in. Oh, look at this. This is horrible. Oh, it's not too bad. So what do we got? 3 over 4 and 71 over, negative 71 over 8 as our turning point. If you want to have decimals here, you can just change your document. I mean, it's a lot of fiddling though. Approximate. Okay, and I can just go there and it'll give me the decimals. So you can graph it. Okay, I can hear my son's bike, so I'm going to stop there. Otherwise, he's going to be so noisy. 45 minutes, or just under 45 minutes. Please make sure that you did attempt these last ones by hand, but I'll make sure I give you some easy ones to do as well. Okay, bye-bye.